All right, let's get to it. Full review from, we're going to do 10 questions. There's 4 here, but we're actually going to do 10. I'm going to fully go over Friday's lesson, and then we're going to do a graph.
Which 10 are we doing on chapter?
I'm going to add 6 more. All right, as we're going through the logarithms, please don't take it for granted and say, I'm going to figure this out some other time. I'm just going to write down the answer. Your test is March 3rd. I've officially written the date down. So I'm giving you a heads up 2 weeks out. This isn't something to just zoom through or assume a calculator can do it for you. It will be best if you really understand what the logarithm's saying. So keep in mind that logarithms solve for exponents. So when it says rewrite in exponent form, this 5 would be the exponent. So the subscript 2 would be the big base. The exponent would go next, and 2 to the 5th is 32. Did everybody try 1 through 4? Everybody's got these done? All right, 27 to the 1/3 is 3. So that's the first 2. Then you need to write it in log form. So you start by writing the word log. Base 64. I always have to write the exponent next because logarithms equal exponent. I know the exponent will go next to the equal sign, and then the 8. And then I'll write log again. It's base 1/3. The -3 is the result, and the 27 goes in the argument spot. Log base 1/3 of 27 is -3. Okay, sounds like you guys had that down. All right, here's 6 more. Going off of class Friday. I'm not sharing that at this very moment. Maybe. Okay. So, the last part of Friday's lesson, we really didn't spend a whole lot of time on, says evaluate. And realize that the first 4 had equal signs. Equal signs, equals. These were all equations. They were already solved. These don't have equal signs. You have to solve them. You have to figure the answer out. So the directions will just say evaluate. You keep in mind that logarithms do equal exponents. So for this one, I would just trying to figure out what it equals. We got a question mark. So this would be 4 to what power equals 256. So I should see lots of calculators out. This is right underneath bell work. This is a part of the bell work, so it could be on the bell work quiz. So Julie, first do them in your head. Do them like this. You know, guess and check with the calculator. What? Yeah, these are still part of bell work. Somebody's out. 4 to the 4th power is 256. So I'm going to put that this equals 4. Put a question mark. 8 to what power is 0.125? If you have a decimal, you want to think of fraction exponents. No, I'm at negative exponents. Negative exponents can make fractions into whole numbers and whole numbers into decimals or fractions. So 8 to what power would give you this decimal? Try something in your calculator. Try a negative number. 8 to the -1 I know is 1/8. So maybe this is equivalent to 1/8. -1. the guessing and checking process with your calculator is really going to become a part of your muscle memory. It's something that you really need to try it yourself. And what you're going to start seeing is repeats. By the end of the chapter, you're going to see the same math facts repeated. So it's valuable to really look at it, read it. Over time, you'll start to remember them. So this is 64 to what power would result in h? So what's the exponent here? I know something like 2, but 64 squared is actually a huge number. 1/2. Remember, fraction exponents are actually radicals. So 64 to the 1/2 is the square root of 64. And look, it's here. It's here. As we go through, you're going to see repeats. So this is 1/2, because that would be the square root of 64 is 8. I know, everyone needs new seating charts all day long. Everyone's struggling to stop talking. It's probably the course recommendation forms, though. It's not a big deal. -3. So with the trick with fractions is pretend it's not a fraction and just look at the denominator. You could think 3 to what power is 27? 3 to the third is 27. So if it's a fraction, just make that power negative, and a negative fraction will make a whole number. This one's really important. You'll see this one with variables. 12 to what power is 1? Chase? 0. Anything to the 0 power is 1. So these last two are the most likely to show up on an SAT because they really show properties of logarithms. Anytime there's an argument of 1, that exponent was 0. And so you could put anything crazy down here, 0.48, and people will be thinking, I have no idea, but it's 0. And then what we're leading towards is you understanding logarithms well enough that you can apply them to problems with variables. So you might be feeling like, I don't know why I have to do this. I already figured out how to do it in my calculator. But understanding what it's doing without the calculator is going to help you when you get to variables. So x, so what power is x? 1. Anything to the first power is itself. So that's an important property. If the base and the argument, the subscript and the argument match, that power was 1. All right, so these 10 questions, the 4 on the board and the 6 here, it's a full review from Friday. If you haven't already, if you wanted to turn in the paper copy of Friday's assignment, it's due right now. Should have been due like 15 minutes ago, but for any reason it's not submitted online, you need to turn it in right now. Okay. Well, there's certain rules that define logarithms.
Yeah. You make it, but it stops at 0. It's log x parentheses x plus x.
Well, yeah, log x parentheses x is just 1.
Log x.
So you have 1 plus x.
And you get a linear.
Is your slope 1 and your y-intercept 1?
Intercept is 1, yeah.
Yeah.
But the slope is
Log x of x is just 1. Just put that out and put it over. Okay. I want to talk about 21 because it's very likely to be a test question. It's very likely to be an SAT question, and your understanding here without a calculator at all is important. So when I look at these, I can estimate them without a calculator. So I don't know what power of 5 is 23. I do know 5 squared is 25. So this answer is less than 2. Does everybody understand that? Since 5 squared is 25, 5 to what power is 23? It has to be less than 2. Okay, I know 6 squared is 36. So I know the answer to this one has to be more than 2. No calculators, just understanding numbers. I know 7 to the first is 7. So that means this has to be more than 1. Not much more than 1, just a tiny little bit more than 1. All right, Shane, so what are we going to do with the last one? 2 to what power would get us close to 10? Yes, 2 to the third is 8. So I don't know what this answer is, but I know it's more than 3. So you can make estimates with your understandings of powers. So then, yeah, this is definitely the smallest. This is definitely the smallest exponent. The argument is very close to the base subscript. And then this is less than 5 squared. So that would be second. This is just over 2, so that would be third. And this one's over 3 times, or a power of 3, so that would be fourth. Your ability to do this really shows how much you understand logarithms without a calculator. Should we try one right now? I should make one up. Maybe tomorrow. I'll make one up tomorrow. You can try again. All right, today we need to go through a graph. So if there's no more questions.
Are we going on big ideas today?
We are.
Yeah, I love big ideas.
Before we get to big ideas, here's some notes for you to do underneath your bell work. Yeah. All right, put your phones away. Put your phones away. So, there's kind of a neat strategy here that's different than all of the other graphing strategies. I feel like every function has a different strategy. Would you say that's true, Eric? Every function we've done has a different strategy as far as making the graph and the table, really understanding the numbers. This one's very unique. In order to graph a logarithm, we're actually going to plug in the y side of the table. That's wild. Look at this table. Normally we start with x values plugged in. I put them on the y side. That wasn't an accident. That's our actual strategy. We're going to plug in these very typical values, -2, -1, 0, 1, 2, to the y side. Boop. Then we're going to consider the exponential form, and we're actually plugging in for y instead of x. Weird.
So, like, the top one would be 1, 9.
Mm-hmm.
Because 3 to the -2 is
So the problem is going to present to you an f of x form. My first recommendation, go ahead and write it with y, which you kind of do naturally at this point, probably when you see f of x, put a y in. The second thing that's a little unnatural about the order is we've been looking like on bell work, the y has always been on the right side. So when you're looking at this is what we're graphing. Log base 3 of x equals y. You want to actually convert it. Convert it to exponential form. Robert, you give it a go.
Convert it to exponential?
Yeah.
You gotta multiply by x.
Oh, I think you might be doing something really hard. So when I look at this one, it's converted 2 to the 5th equals 32. Alejandro said it, and I see a lot of people knew it. 3 to the y equals x. So instead of trying to make a table with the log form, I'm actually going to encourage you starting out just to consider the exponential form. This is just one strategy. There's lots of different strategies. So what we're going to do is we're going to plug in the y spot here, and that's going to help us figure out x. So 3 to the negative 2 gives me the x value. 3 to the negative 2, Eric, you know that? Yeah. Yep. And then we'll do 3 to the negative 1 equals x. What's 3 to the negative 1? 1/3. And then we'll do 3 to the 0 power equals x. What's 3 to the 0 power? 1. And then things are going to start looking easier. 3 to the 1st is 3. And then 3 squared is 9. So here's our ordered pairs for our log graph. It's 1/9, comma, negative 2, 1/3, negative 1, 1, comma, 0, 3, comma, 1, 9, comma, 2. Very different strategy here, filling in the y's first and solving for x. But over time, you can actually look at the equation and start to understand, oh, I know what I'm looking for here. I'm looking for powers of 3, or I'm looking for powers of 4. How do I graph 1/9, negative 2? That's so weird. 1/9 is just over 0, and then negative 2 will be right about there. I'm going to redo my axis, actually. You can see how far over it is. Much better. And then 1/3, negative 1, 1, 0, 3, 1, 9, 2. You start with your pencil very close to the y-axis and then move up and over. Shane, you think you can do domain and range?
Yeah.
Let's hear it.
Oh, let's hear it. Okay. So y is positive infinity, negative infinity, correct?
Correct.
Okay. And then the x is 0, or I think to infinity.
Yes.
So it'll never hit.
No, because if you think about values for y that could go in, let's say we put negative 10 in, it's a fraction. It's a positive fraction. So looking back to the beginning of the chapter, we graphed y equals 3 to the x. And I used the word asymptote to describe that. It looked like this. And it had an asymptote that was horizontal this way. This is its perfect inverse. Y equals log base 3 of x. So it's congruent. It's the exact same shape that we graphed in the beginning of the chapter. So that's going to be challenging on test day, is realizing the difference between an exponential graph and a log graph. The log graph has a vertical asymptote, at y equals 0, and the exponential graph has a horizontal. Oh, I just switched that around. That one's y equals. And that one's x equals. All right. When you go to answer your questions, it's going to talk about positive, negative, increasing, decreasing. So it's positive above the x-axis, so when x is greater than 0. It's negative just in this tiny little bit when x is between 0 and 1. It's increasing the whole way through, and it never decreases. So